Welcome back to STS. In today's video, we're going to be working with a definite integral. Our question of the day is to find the area under the graph f of x is equal to sine of x over the interval negative pi to pi. And we see this interval is inclusive because of the square brackets. All right, let's begin by drawing in our integral. Our lower bound is here, our upper bound is here, and we're trying to find the sine of x dx. First thing we do is we need to integrate sine x, and sine x integrates to cosine x. And again, with the notation with the square brackets, I'm going to show my lower bound at the bottom, my upper bound at the top. My next step is to substitute in the upper bound and the lower bound. I need to subtract the lower bound from the upper bound. So I'm going to write in negative cosine, and instead of x, I'm going to place in pi. I need to subtract those two quantities, so I'll put my minus sign here, and I'm going to use parentheses because the cosine x is actually negative. So parentheses negative cosine, and instead of x I'm going to use the lower bound of negative pi. Close of my parentheses, and now let's just take a brief look at the unit circle to help us evaluate the cosine at the values of pi and negative pi. Alright, let's begin with the upper bound. So all I'm going to do here is I'm going to draw a unit circle. With the unit circle, I know the radius is 1. So that means when I come back to this point here, it has coordinates of -1, 0. And as I work my way around the unit circle in a counterclockwise fashion, this here is 0. Up here is pi over 2. This location is pi. And down here is 3 pi over 2. Our concentration is here at pi because that's our upper bound. And we know that the x value corresponds to the cosine trig function. So at pi, the cosine at a value of pi leaves me a result of -1. And let's take a look at what this unit circle looks like if we're dealing with negative radians. Again, this location here is going to be -1, 0. And if we work our way around clockwise this time, 0. This here is negative pi over 2. Over here is negative pi. And up here is -3 pi over 2. Again, we're focusing on the lower bound of negative pi. So that means we care about this x value of -1. So we see that cosine at pi and at negative pi both give us a result of -1. Now we just make the substitution. Here, putting my negative, cosine of pi is -1. Notice the parentheses so I don't get these negative signs mixed up. Minus, negative, and here cosine of negative pi is actually -1. And again, I place in my parentheses. I have a negative and a negative, which makes that a +1. I'm going to rewrite this negative, and again, a negative and a negative makes this here again a +1. And I have 1 minus 1 to give me 0. So the area under the graph the area under the graph for the function sine of x over the interval negative pi to pi actually gives me a result of 0. Now at this point, let's pull up the calculator so that we can verify these results. All right, here with the TI 84 calculator, let's press the y equals to get to the graph. Notice I've already placed the sine x function here in the graph for the y equals, and now let's press the graph button so that we can see what it looks like. Alright, once it's graphed in, again we see it working because of the yellow pointer that was there. The other thing you want to do is make sure to make this easier seen for your zoom, make sure you select 7 where 7 is for trig. I'm going to do that and let it draw itself back in. So now each one of these intervals is actually a unit of pi. So we have 0, pi over 2. This here would be pi. If I go in the left direction, this here would be actually negative pi over 2 and a negative pi. Now let's click on the second key, and let's go to the trace button because I want to get to the calc functions. From the calc functions here at number 7, I see where I can actually integrate over an interval. So I press 7. And if we look here, it asks us for the lower limit, and we can actually type in that lower limit. So we're going to press second, and well, actually not that. Let's clear. Let's do it again. We're going to do second and then calc. I want to press 7. I need to make sure for the lower limit I need to put in my negative and then hit second, and I want pi and press enter. Notice how it shows my lower limit, and then it's asking for the upper limit now, so second, and that's going to actually be at pi, and then press enter here, and then notice how it shades in the area under the curve. Note that when the area shaded is underneath the x-axis, that area is depicted as negative, and we're above the x-axis, that area is depicted as positive. We see that we have symmetry here, so we have this negative area minus the same exact positive area, which gives us the same result that we calculated by hand of being 0. Alright, that sums it up for this video. Please subscribe to that YouTube channel, and as always, thank you for watching.